Hi, Solving Science, episode 6, maybe an awkward one. Global news has gone crazy this week saying Stephen Hawking's 1971 theorem on black hole event horizon surface areas has been confirmed by gravitational wave detectors. Why is that awkward? Well, expanse tension theory says gravitational waves don't exist, so that should potentially be a killer blow for expansion tension theory, but I'm still smiling, so why is that? Firstly, what did the theorem say and why? So two compact objects like neutron stars or black holes, when they collide, the theory says that the surface area of the previous two objects must be retained. Because these are ultra dense, extreme density in the case of a black hole, the residual remnant surface area can't be less than the combined surface area of the previous two black holes. Now, that makes sense because you can't make it any more dense than it already is. It's already a black hole. It's at that infinite scale of density. So that makes sense. When two objects like black holes come together, that merger creates a massive ripple in the fabric of our universe. It's called ringdown. It's like ringing a bell and you get an oscillation, a resonant frequency that creates ripples that we claim then transmit across the universe. Now herein lies the problem. Space-time, as I've said before, is not a medium, it's not a fabric, it's not a material, it's not a quantum field. There's actually nothing there. It's a geometry, it's a manifold geometry, but there's nothing there. It can't store energy. It can't hold energy in any way, shape or form based on how space-time is described. Now that gives scientists and engineers like me a big problem because sound waves need something to propagate through, like air or material or solid things or water, and even electromagnetic waves still need the electromagnetic force in which to propagate through. But space-time is just different. You don't need any kind of medium to propagate through. Lots of people have a big problem with that. How are gravitational waves detected? Well, you have two really long arms set at 90 degrees apart, more than a kilometre long. And as a ripple in the fabric, the space-time, whatever it is, as this ripple comes through, because they're at 90 degrees to each other, one of them will experience greater ripple effect than the other. And as you split a laser beam in two and shine it down the length of these arms and back again, if there's a difference in when the light is returned, it's evidence that the ripple changed the length of one of the arms and therefore evidence of a gravitational wave. Now, the good thing is expanse tension theory predicts expanse tension ripples, a ripple in an actual quantum field with an actual medium that can have residual energy storage, which again I've talked about before. The effect that's being measured by LIGO and Virga, and I think it's Karga, would be exactly the same. So a ripple in the Holland field within expanse tension field would be detected in exactly the same way. We'd see the same thing. So what has been proven to 5 sigma and 99.9999% is that the surface area of merged compact objects retains the minimum surface area. Proven. What has not been proved is that gravitational waves, or these ripples that have been detected, are gravitational waves within space-time. And actually, it's in expanse tension's favour that we're now seeing these results, because it's far more likely and parsimonious, and in engineering speak, in a mechanical speak, it's far more likely that waves are being propagated through a medium or a fabric that exists, which isn't space-time. Now, final point on this, because the prediction says as the accuracy of gravitational wave detectors increase, expanse tension theory predicts they might see something unusual. So I have a long list of things that say the gravitational wave theory will break down at a certain level of accuracy of gravitational wave detectors. And one will absolutely prove if there's any persistent resonance or retained energy which could happen, which a gravitational wave cannot support in any way, shape or form. So the slightest hint at some kind of propagation of an energy that's being held would discount the fact that it's a gravitational wave within space-time. So, still in the game, gravitational waves prove a theory, but actually they're a ripple in something. And okay, this is kind of where I get to. So it's like the little boy saying, hey, Emperor, you're naked. Because most scientists and engineers agree that you can't propagate a wave through nothing. And that's what space-time says are gravitational waves. So this now for me should raise a real discussion about what are gravitational waves passing through. And I hope it raises the possibility that people look for expanse tension ripples within an actual quantum field. Okay, so thank you very much. Bye-bye.